Welcome to the AP Calculus BC video for skill number 236. I can use the first and second derivative test and the concavity test to help explain the shape of a graph. Speaking of shapes, below we have the diagram of the saddle, and in the last video the trivia question was about the word pummel. This time we're going to go to the back side of the saddle, and the trivia question is about the word cantle. So cantle means the back of the saddle, and the trivia question is, what is the only other 6-letter anagram for the word cantle? C-A-N-T-L-E. 6-letter anagram. And if you remember, an anagram is when you switch letters around and it spells a new word. Alright, the first derivative test has 3 conditions. The first is if f prime changes from positive to negative at c, then f has a local max at c. So if we are increasing, we have a positive f prime, and if we switch to a negative f prime, then that value of c is going to be a local max. If f prime changes from negative to positive, then we have a local min, and if f prime has no sign change, then we have neither a max or a min. The second test is the concavity test, and the concavity test says if f double prime is greater than 0 for all x in the interval, then the graph of f is concave up on that interval. And what exactly does concave up mean? Concave up means that for all values within the interval, the tangent line is located beneath the curve. Likewise, if we take the second part of the concavity test, which says if f double prime of x is less than 0 for all x in the interval, then the graph is concave down. So here we have a concave down graph, and if you notice, all the tangent lines, if I can draw well, wind up being above the red curve, which is concave down. The second derivative test actually combines a little bit about the first derivative and the concavity test. And we're going to suppose that f double prime is continuous near c. So if f prime of c equals 0, so if we have some curve and at c our f prime is 0, we have a horizontal line, and f double prime is greater than 0, then we have a minimum. So in the first case we have something like this, where f prime is 0 and f double prime is greater than 0 because we've got it concave up. So we have a minimum at c. And in the second case, if f prime of c is 0 and f double prime is less than 0, we've got a concave down scenario, and if it's concave down, then we're going to be talking about a local maximum. So these 3 tests we should be pretty comfortable with. We should be pretty comfortable with using these 3 tests. I'm going to show one example how I used them. You're welcome to kind of demonstrate your own understanding in your own process, but let's take a look at them. Example 1. Find the local max and min, or mins, or maxes, for f of x equals x to the 4th minus 4x to the 3rd, and the intervals of concavity. In all examples, when I am going to talk about max mins, intervals, and sketching, and all the jazz that we're learning about right now, I always start off by writing f of x, f prime of x, and f double prime of x. So that way I can work with these functions. And sometimes it's useful to write them in a factored form, which I've done here, because what that does is it allows me to find the critical points of each form much faster. So the factored form of f prime of x, I find that there's critical points or critical values at 0 and at 3, and I find that the second derivative has critical points at 0 and 2. So, now that I've found the critical points, I can use the second derivative test on those points. And the second derivative test, we know f prime of 0 is 0, and f double prime of 0 is neither greater than 0 or less than 0, so it is neither concave up nor concave down, so we can say there is an inflection point there. Then we apply the second derivative test to the critical value of 3, and we find that f prime of 3 is 0, so we know it's going to be possibly a maximum or a min. The second derivative is greater than 0, so we know that it is concave up. So if it's concave up and the tangent line is horizontal, then we know we have a local minimum at x equals 3. Going back to the question, it said also identify the intervals of concavity. So because we've identified that 0 and 2 are our two potential inflection points, then what I've done is I've created a sign chart here where I plugged in 0 and 2, and then I created test values for each interval, and I plug those into f double prime. So f double prime of -1 is positive, f double prime of 1 is negative, and f double prime of 3 is positive. So I know that we are concave up from -infinity to 0, and then we are concave down from 0 to 2, and finally we're concave up from 2 to infinity.
You can call me Queen Bee, and baby I'll rule. Let me live that fantasy. Oh.
And of course all of this folds into learning how to effectively sketch a graph. I had the function x to the 4th minus 4x squared, was it? I think it was 4x squared, 8x, nope, it's 4x to the 3rd. Okay, so 4x to the 3rd, and we are able to find the intervals of concave up versus concave down, and the inflection points, and eventually that would lead us to being able to sketch some sort of curve which looks like this, where you've got the inflection point at 2, the inflection point at 0, the minimum at 3, and voila. So all these ones that fit under the kind of category of curve sketching will probably be in the form of one skill test where you're sketching the curve. Alright, thanks for watching the video. At this point you should be able to use the first and second derivative test and the concavity test, and the way you display those can vary, but the key ideas is understanding what each of the three tests do. The answer to the trivia question is an anagram for the word cantle is lancet. And a follow-up question is, what is a lancet? I'll leave that to the reader.